welcome to the next section in trigonometry. Now that you're familiar with the sine, the cosine, the tangent, SOHCAHTOA, there are two triangles you should really get to be familiar with. And as you go forward in math, you're really going to need to know two triangles and 4 points on the unit circle. Now we haven't introduced the unit circle yet, so we're going to look at this as 3 triangles you need to know. And these are the 5 angles that, as you go forward in trigonometry, which is going to show up in pretty much every class you take from here on out in mathematics, these are the only values that are going to come up and be expected of you to know without using a calculator. And very often in mathematics, your teacher would like you to solve the problem, receive an exact answer, meaning not using a calculator. And so you'll see these values coming up over and over again, even if they're hidden behind something like 120 degrees or negative 180 degrees. These are really the 5 values that you need to become comfortable with. Okay, the first triangle. And now really there are, again, only 2 triangles that you need to memorize. The first triangle is going to be in a ratio of angles with 30 degrees, 60 degrees, and then the right angle, so 90 degrees. So this is often referred to as a 30, 60, 90 triangle. Okay, now the sides are in these ratios. Across from the 30 is a side of length 1. Across from the 60 is a side of length root 3 or square root of 3, and across from the right angle is a side with square root of 2. Okay, this is something that you should be able to recall on the upcoming quiz, on the upcoming unit test, and in future maths you should be able to recall this. So an easy way to remember this is you start with a blank right triangle. Doesn't really matter what it looks like. It just maybe shouldn't look like an isosceles triangle, but again, we always just say it's not to scale. So the size doesn't matter so much. Okay, you remember your angles. You go, okay, I've got a 30, a 60, and a 90. And you remember your numbers in any order. You say, there's a 1, there's a 2, and there's a square root of 3. Okay, and then you just got to think about their values and their size. And you go, okay, well, square root of 3 is between the square root of 1, which is 1, and the square root of 4, which is 2. So it's somewhere in between 1 and 2. So let's just say it's 1.5. It's actually around 1.7, okay? But it's somewhere between 1 and 2, all right? So the way to remember this is that you have the small angle is across from the small side, all right? And then you have the medium angle is across from the medium side. And we talked about this in class a few times. You'll learn the exact rule that goes along with this. It's called the law of sines, or the rule of sines. Now, you can easily find out that, okay, the 30-degree angle is the smallest, okay? And now out of 1, 2, and around 1.5, the smallest is 1. So we say across from there is the side of length 1. Across from our 60, which is our medium angle of the 3, we have the medium side, which is root 3. So across from our 60 is our root 3. And then across from our biggest angle is our hypotenuse, so our 90-degree angle on our hypotenuse, and the biggest side is 2. Okay, so that's an easy way to remember which sides go where. And then from there you can find the sine, cosine, tangent of 60 degrees, of 30 degrees, and so on. So that on any future quiz or test, you can quickly sketch this triangle and use this to solve your problem. Now our second triangle to remember, it's also very easy. We just start with a 1 here and a 1 here. Okay, and we say, all right, well, what's going on here? Well, we know this is an isosceles triangle. So if 2 sides are equal, we know the 2 angles are equal. And we can say, okay, well, the angles add up to 180. We subtract the 90-degree right angle. And we say, okay, well, 180 minus 90. And then we take that and divide it by 2. And we get, okay, so each of these angles must be 45 and 45. So this is our other triangle of 45, 45, 90. right? And then we can use Pythagorean theorem to find out that other side. And so we get 1 squared plus 1 squared equals c squared. And we get 1 plus 1 equals c squared. 2 equals c squared. So c is the square root of 2. Okay, so these just happen to be our two triangles that had easy exact values both for the angles 30, 45, 60, and for the sides 1, square root of 2, square root of 3, and 2. So this way, in the future, we can have you explore sine and cosine tangent in ever more interesting problems, and without having to resort to decimals and a calculator and approximations, we can ask you to explore different identities, integration, and calculus using these exact values. Okay. Now I'll just put the triangles side by side. All right, here they are. So commit these two to memory, be able to recall these on the homework. Your entire homework is actually based on these two problems. I'm just going to explore really quick one more imaginary triangle, as it were, that we'll actually look at a different way in the future. So you can stop here and go on to the homework. At the end of this video, I'm going to do a couple of your homework problems for you, just so you can see some examples. Okay, for this third triangle, we're going to say, let's start with a triangle that looks like this, okay, being a right triangle. And let's say we made this angle smaller, okay? And then let's say we made it even smaller, okay? And then let's say we made it even smaller. And if this pattern continues, eventually we get a triangle. And again, this is an imaginary triangle. This doesn't actually exist. But we would get a triangle with a 0-degree angle, and with then 0 and 90, subtract that from 180, this would be a 90-degree angle. Okay? Now this triangle may not really exist, however, it does give us correct values for the sine, cosine, tangent at both 0 degrees and at 90 degrees. Okay? So this is a nice, easy way to think about this. So if this is a 0-degree angle, then these two lines, this top and bottom line, are actually on top of each other. So if we just pick a number, let's say 1, right, great number, then this top side is also 1 because they're lying on top of each other. There's a 0-degree angle between them. So they're both 1. And then this side across, if it's a 0-degree angle and these are both the same line right here, well then the distance between them is 0. Right? And so this would actually let you find out, even though this triangle is kind of a make-believe extension of right triangles, you could say, all right, well, what is the sine of 90 degrees? So referring back to SOHCAHTOA, you would say, okay, I've got my SOHCAHTOA. So the sine is the opposite over hypotenuse. And so we would say, okay, well, the opposite side from 90 is 1. And we would say the hypotenuse of this right here is 1. So the sine of 90 degrees is 1 over 1, or equal to 1, which is the correct value. So this imaginary third triangle lets you explore both 0 degrees and 90 degrees. And then tomorrow, as we introduce the unit circle, we'll look at this in a different way. All right, so I'm going to do a couple examples from the homework now. Okay, problem number 1, pretty straightforward. Just explore these triangles. Okay, so you could just draw them really quickly. You say, okay, I've got my 30, 60, 90. All right, I've got my 1, 2, and root 3, which is around 1.5. Okay, we say across from 30 is our smallest, so 1. Across from 60 is our medium, so root 3. And across from our 90 is our biggest side, which is 2. All right, and then over here we have our isosceles triangle, where we've got the two sides equal, the two angles equal, and then Pythagorean theorem gives us that last side is square root of 2. Okay, so we've got our two main triangles drawn. Let's just pick one here. Let's say the tangent of 60 degrees. Okay, going back to SOHCAHTOA. We'll write that right here in the middle. SOHCAHTOA. Alright, tangent is opposite over opposite over adjacent. So you got B is tangent of 60 degrees is, and we say, okay, in our 30, 60, 90 triangle here, we have opposite, square root of 3, over adjacent, 1. So our tangent is square root of 3 over 1, or just equal to anything divided by 1. It's just itself, square root of 3. Great, right? So I'll leave the rest to you. And let's move on to a harder problem. Okay, so now they're having us explore a couple identities. You see here the double angle identity, which you'll learn about later. But what it's saying is, if x is 30, show that this is true. Okay, so first let's just plug in the value. Okay, so you could get sine of 2 times, we plug in 30 degrees. Okay, and then we get equals 2 times sine of 30 degrees. And then we get cosine of 30 degrees. Alright? So that leaves us with the sine of 60 degrees equals 2 sine of 30 degrees cosine of 30 degrees. Oh, okay, so all we need is, our 30, 60, 90 triangle here. I'll draw it in the bottom corner here. So 30, 60, 90. We've got our sides, 1, 2, and 3, which we could write in a better order next time. But smallest side, smallest angle, medium side, medium angle, and biggest side, biggest angle. Okay, so sine of 60 degrees is root 3 over hypotenuse, so root 3 over 2, equals 2 times the sine of 30 degrees is 1 over hypotenuse, 1/2, times cosine of 30 degrees, which is adjacent root 3 over hypotenuse, so root 3 over 2. Oh, and sure enough, look at that. 2 times 1/2 just cancels out to leave 1, right? And 1 times root 3, we get root 3 over 2 equals root 3 over 2. Okay? Put a little check mark there. That worked. Alright, and finally the last problem you're going to see on the homework is identifying missing sides in an enlarged 30, 60, 90, 45, 45, 90 triangle. Okay, so let's do B here. You have, okay, so we've got the opposite and the adjacent, so we're looking at the tangent, but before we start anything, we should draw our triangle. Okay, so we've got our 30, 60, 90 triangle. Alright, we've got our sides 1, root 3, and 2. So they're in order from smallest to largest. Across from 30 is our smallest side. Across from our medium angle is our medium side. And across from our biggest angle is our biggest side. Great. Okay, so using similar triangles here, we can just say, alright, well B, I'll start with a variable, that way it's on top and it's easier to solve. So set up a simple ratio. B is to 2 as, and then over here we get the side next to our 30, root 3 is to 1. Okay, and then solving, we just multiply both sides by 2. And of course that 1 is unnecessary, dividing by 1. And so we get B is equal to square root of 3 times 2. And just to avoid confusion, we write the 2 first times square root of 3. Great. Alternatively, you could have done this using the sine. You could have said, or cosine tangent, right? So we could have said the tangent of 60 degrees is equal to B over 2. And then rather than punching the tangent of 60 degrees into a calculator, we look at our triangle over here and we say, okay, 60 degrees, our tangent is square root of 3 over adjacent 1. So we would say square root of 3 over 1 equals B over 2. And again, same step, multiply by 2, multiply by 2. The dividing by 1 is unnecessary, and so you get b equals 2 square root 3. Okay, so using either method, either similar triangles or setting up with the trig function, you're going to come to the same value. All right, well, good luck on your homework. If you have any questions, feel free to email me. I'll be available tonight via email. Otherwise, I will see you in class tomorrow.